Let's see. Okay. Okay, let's see. Can you guys hear me? Excellent. Probably gonna wait a couple of minutes before we start the code walkthrough, just to make sure people get the chance to join. And so basically gonna do pretty much a full walkthrough of the code for Sidestep Legends, or at least an overview. Won't be able to stay and look at all the details because that would take too long. And if you have any questions about either what I'm going through at the moment, or any more general questions about the development of the game, just type them in the chat and I will answer them when it seems appropriate. So I'll probably stop and answer any questions about the current thing I'm going through, and any more general questions I'll wait and answer at the end. Well, yeah. Time is 3 o'clock, so let's start. So if you, I guess people joining here are not completely new here and knows about the game Sidestep Legends. Maybe I'll just show a little bit of it, so anyone that doesn't know gets a bit of context. Let's see if I can find the trailer for the game. Yeah. And let me just add that. Like that. Yeah. Okay. Maybe it works like this. No. Apparently not. A bit new to the whole streaming thing. Let's try something else. Let's see. Does this not work either? That's weird. Okay. Jump scare. Oh yeah, sorry about that. Okay, let's do it like this then. This should work. Okay. So here's the trailer for the game. It's a MOBA-inspired action roguelike game. So it's a little bit like Vampire Survivors, but with the additional focus of dodging different abilities that you can find in your favorite MOBA games, such as League of Legends and Heroes of the Storm. And yeah, it's a 3D low poly art style game, and I made this with in C with the help of a game library called Raylib, and yeah, and of course it's available on Steam for anyone that hasn't tried it and want to check it out. There should be a link in the description of the live stream. Yeah, so this is what the game is about. So let's head to the code and have a look at how it actually works behind the scenes. So I'll start here in the very well-named file, core basic window. It was the name of the Raylib example, and I never changed it. And this whole this file is a bit of a mess. I never really took the time to clean it up. Well, you'll have to see. So I start with a lot of initialization for different things. Start with initializing a crash handler that's supposed to create a mini dump if the game happens to crash, that people can send to me, and I can have a look at what actually caused the error. And then some stuff we just set up the window with a window name and some generic things about that, initializing the audio device. And also here at the start initializing Steam, so the game can talk to the Steam client. And there was some extra stuff that I needed to do here because Steam doesn't really officially support C. It only has like a C++ API, and but there's sort of an official C API. It's just a little bit more hidden, and there's not some things that you had to do yourself. But I got it working in the end. And here also sets up everything, like connected to the different leaderboards on Steam, and also creates any directories needed for the save data. And then after that, just loading things needed to show the loading screen, and then the very beautiful static loading screen that you might have seen depending on how fast your computer is. And a bunch of setup here. Initializing threads for multi-threaded animation. We will have a look at that later. And loading all the different shaders. Let's look at the little bit more interesting assets that gets loaded. And here is just textures, but we can have a little look on how it's loaded, because it might look like we're loading the actual source images, like PNG files. But what I have done is that I have a asset build step before, so I don't have to ship any source assets, because I'm using a few like asset packs and stuff like that, and those usually have license requirements that don't allow you to ship the actual source assets, for example, and it's also less efficient to load. Like, it takes time to load and decompress a PNG, while loading a more raw image from disk is probably going to be faster. So this is using the RS library. That's sort of an extra library from for Raylib. It's made by the same guy that originally made Raylib. It can also be used standalone, but it's made to be. Raylib has official support for it. So everything gets packaged in this in like an RS file, or you can have several. I have everything in one. So all the images, all the models and audio is in one big file, and then you just load that and then load the different files consist in that big file as chunks of data. So here we have like the header for that library that's gonna read the actual data from there, and that's the RS Packer is an application that you can buy that makes it easy to pack these things from command line, which I highly recommend. Also made by Ray, the guy behind Raylib. And let's go back. Yeah, here we also just initialize the shadow map. The shadows in the game is just using a typical shadow map. Yeah, but let's skip ahead a bit. We'll go back here later and talk about the models, because on top of this asset packer thing, I also made some custom adjustments for this game. So because I didn't want to, so even if I could have just packed the source or sort of source models, like the model you get from when you export from Blender, I exported into an IQM format, which was a format that Raylib supports for animations and 3D models, and that's. But I didn't want to load that format in the game because that took some extra time that's not needed. So I figured that I might as well just load the actual model format that Raylib uses internally to store its data, which is like this format defined in this struct here. So I made this, let's see, not here, it's in here, so no, here. So you have this asset export utils, which is a sort of a small library that I wrote that has functions to save. Let's start with the save, because that's, or export static model, or let's look at export animations. Yeah, I think it is export static model. It's just named a little bit weird. So this takes a model from in the Raylib format. So what I'm actually doing in the asset packing stage is I have a different entry point, different program that just here in the export model. So it takes a file path to a model file that Raylib can load, and loads it with Raylib. And then when I have the model file, I can use that to export, to convert it to just the raw data and export it to my own file, so here it just takes the raw binary data from the model file and makes a little header with any information needed to know how to read the data, and then we can save those in the file format I call RLM, just for Raylib model, and those are the model files that then are packaged in the big asset file. So that speeds up the whole reading model process a bit. So let's go back to, now we're back here, and then we get the model directly. Don't need to do any reading of any source data. Just the raw binary data directly into the model struct. So that's the asset loading, pretty much, and it's just a bunch of that here for all the different textures and models, and the same goes for the sound and music as well. And let's see, in the we can talk about the skill tree later, and same with the upgrades, because that's related to the skill tree. We take that afterwards. And here's more. Okay, let's see, we have a question. Why not take the model as a pointer? Okay, let's see. Can head back here. In I guess you meant in the export static. Yeah, okay. Yeah, basically the model struct doesn't really hold that much data, so it doesn't really. It's just that it doesn't matter much. All the big data is pointers anyways. So, and I'm not gonna edit it, so it really doesn't make much of a difference. When parsing a struct like this, it might be a little bit faster to pass it as a pointer, since I think in the Windows ABI it's gonna have to be passed as a pointer anyways, because it's too big to be put in a register. But this is only run this while before running the game, like when building the asset, the big asset file, before updating the game. So it doesn't really matter either way, and yeah, it's like not that many bytes to copy anyways. But yeah, no real reason, just laziness, I guess. So let's head back init data. Okay, yeah, and more models, more textures, and shaders. This could probably have been cleaned up quite a bit, but it's only been me working on the project, so it's not that important. I would want it more. It would make sense to have it much more structured and cleaned up with several people working on the same project, but here it doesn't matter that much. let's see if there's anything more interesting in this loading thing. We have the particle. We can talk about the particles when we get to the logic stuff. And let's see. Set material texture. Yeah. Okay. And then just loading some. Yeah. It's some cursors. It's pretty much the same thing. Init level. Yeah. It's the same stuff here, but with the actual level things. Maybe. Yeah. I could take a bit of time to talk about that as well. So I also made a. I think I made. Yeah. So here I made a separate format for the levels as well. So since Raylib is just a library where you just write code. There's no editor or anything like that, like in Unity. So I had to make up some way to be able to make 3D maps a bit easier. Just placing everything by code would be too annoying and take too much time, and yeah, it wouldn't work out. So I opted to use Blender for that. So let's see if we can get Blender showing. Yeah. So here in Blender we have the first map of the game, which has been designed here inside Blender with a bunch of different assets that I bought from an asset pack. So this then I export this whole thing as a GLB file. I think that's what it's called, like the GLTF/GLB format, which Raylib also support, which is a good format to keep like all the transforms and positions in a big scene. So basically, it can represent the whole level, and then read that in the asset build step. I read that file and extract all the information I need for the game in runtime, and save that. So we only need to load in the actual information, which is basically the different meshes and their positions. And it also tries to find any duplicate meshes and only store the transforms for those new meshes, and not have to store the vertices for each and every one, to make both save space, but mostly to make the rendering a bit more optimized. And in addition to that, also in here I designed like the collision geometry, because I didn't want to check collision against the actual geometry, because that would be a bit too slow. At least with the maybe it could have been made fast enough with some more advanced collision, some more advanced algorithms, but I didn't want to bother with that, so I made more simplified geometry for the collisions. And so I export those as a separate step. I think if we head back to the code, I think we can see those. Yeah, here, so the colliders are the separate file, and we also have the minion path. So if we head back to Blender, so how the minions move around on the map is defined, also set up here. So they are starting with one at one of these. Some of these cubes are like spawn points. I think it's this one, this one, this one, and this one, and this one, and then they just follow them in the order that they find in here, and walk to the last one, and then go all over again. So this can be designed in Blender, all the things, and all the other maps were also designed like this inside here. A 2D collider would also work. Yeah, technically a 2D collider would work, since the game logic is 2D, but it was easier to visualize it like this. Maybe it could be, the collision detection could be optimized a bit. I could still keep these and just do the actual collision logic in 2D, but right now it's actually in 3D, because there wasn't really any issues with performance on that part, so I didn't bother with it. But yeah, that's true. So let's head back to the code. Yeah, so that's how the map works. We can take a quick look at the render level, I think it's called. Yeah, how it's rendered as well while we're at it. So I have this level render object, which is what we get from the asset build step when we have exported the level from Blender. And so this holds like the number of unique meshes and unique materials, if there are several materials, and then also the instance count for each of the each mesh type, and then transforms for all the instances, and then materials for the meshes. Oh no, this is all materials for the level, and then the actual material that a certain mesh should use. And I also calculate bounding spheres for all the objects that's used for culling while rendering. So it's handled in like in two different paths. One for few instances, like, or one for many instances, like above 50. Then we do an instanced render call for it, and if there's fewer than 50, we just render them one after another with one draw call each. I just tried some different numbers on my different testing devices, and these seem to be a good trade-off. Some GPUs have much more overhead with the draw mesh, like instance drawing, than others. For example, I think the integrated Intel GPUs had a bit more trouble with the instanced one, so it had to be higher instance count for that to be worth it. So that's sort of how I got to that magic number. And then it's just, it checks if this should be rendered at all by checking the bounding sphere against the view frustum, which I just approximate as a sphere. So the whole calling thing could be improved quite a lot, actually. But it was good enough for me, so I didn't want to put more time into that. Let's head back to here, and then we're okay. Unload sounds in Raylib is just it says all the others will load it from the RS file, and we just get different sound objects for those. And load players is the same thing. Here's models, but also some animations for the characters, but they're just saved in another format. But it's the same thing there. loaded in directly into the format that Raylib uses. And let's see, gameplay data. That's a little bit more interesting, at least. So here is the setup for all the base values for everything. So this is, we run this as startup, but also between every new game. Let's see. We do the init player stats, which just set up the different stats for all the different characters. So I have an enum for all the different type of characters in the game, and then we just all the values for each character is just set up as constants here in the code. So pretty much all the gameplay data, so to speak, is it's defined in the code. It's very, I don't have any like separate data management thing that to set up these things. I just write them as constants here in my constants file for all the different stats. And let's see. And in here, yeah, I just said the same things, but for the maps, it sets up all the data for the different maps. They have like different color for the sun, and like the lighting is different on the different maps, and it's also supported to have different colors for some spell effects to make them stand out a little bit more when needed in different lighting. And like all the different values in the game is set up here. And here we load the ability. What was the biggest challenges with Sidestep Legends? Yeah, let's probably. Yeah, we can talk about. I'll answer more general questions like that after the code review, I think. Let's see, and yeah. So player abilities is sort of quite a big thing in the game. In the code, it's just defined as a struct, which just holds the cooldown, the cooldown left, and its type, which is just an enum for all the different type of abilities that are in the game. And let's see. And yeah, they can have a duration and the distance and charges. Like some abilities, you can have several charges stacked up, so you can use it more than one time without it going to cooldown, like for the dash ability, for example. So there's not much data here. All the data for the abilities didn't end up here because they were some of them were quite different, so there's some more data spread out for some of them. But here I set up all the player abilities in the game with the different values. And let's see. Yeah, and then just some more stuff. We can have a quick look at the upgrades. So these are the in-game upgrades that you get when you level up. This file is quite big. Everything is defined in here in this upgrades file. So yeah, it's a few thousand lines of code in here, but they are defined like this pretty much. They have this upgrade struct, which holds the description, the name, and a pointer to the upgrade function. and then how many of this upgrade that's left in the pool. So some upgrades there might only be one of. Most of them are like 5. I think that's the max for anyone, any upgrade. And there's also a weight in here, which is used in the when randomizing the upgrades. Some upgrades are more rare than others, and a high weight means it's more common. Low weight means it's gonna end up being picked less often. And then just cooldown and icon information that's used for displaying the information about the if the upgrade is an ability, then the cooldown is going to be set. Yes, so here we set up all the different upgrades, all of them. And here at the end we also have like the unique upgrades. Those are the upgrades you get from the boss, and each character also has one of these at the start as well. They are quite similar, just missing, like the count is not needed here because there's only going to be one, and otherwise it's pretty much the same. And then I have a bunch of methods, or a bunch of functions that says if certain upgrades or conditions has been unlocked, because some upgrades is only going to be available when you have, for example, like 2 different abilities unlocked. Then those are going to unlock a combo upgrade. So that's what this is all about. And section, yeah, and a bunch of code to check that. And then down here is like different upgrade functions. So for example, one upgrade in the blink length is just increases the distance of the blink ability. So enough about the upgrades. And this array holds the selected abilities, like the 4 abilities you can have in a game. And in here we set up that for the different characters. So this is, you run this on the selected character, so whenever you switch which character you want to be, you and run this function. Oh, let's see. Oh, this Dyson Dev, thanks for the donation. Nice work, keep doing your thing, and I'm excited to see what other games in C you come up with. Yeah. I am working on a new game in C with and Raylib right now, which hopefully I'm gonna have some things to show quite soon. Yeah, thanks man. And these are yeah, so the selected character, you send it in here, and then it's just gonna set up different things needed for different characters. It's quite similar for most of them, but for example, the basic attack effects are different on a few of them. They have the different unique upgrades that they start with, and then also you can select different starting abilities for different characters as well. So that is set up here as well. And basically, if dash, for example, is a selected ability, we just unlock that one in here. and make sure that it cannot appear in the pool of upgrades. Some more things. Yeah, I think that was all the data loading. Let's head back to here. And yeah, more setup with materials and shaders things. It's a bit of a mess in here in the main file. Should probably clean this up, but since I'm not really working that much on this game anymore, it's not really worth it. Loading some settings and setting the game state. So the game is divided in by this game state, pretty much a game state for each screen, you could say. So there's one for the main menu, for character select, playing, settings, upgrade, which is actually the skill tree, and then the leaderboards, which is its own screen as well, and then 3 that's not really used in the actual game. It's some debug stuff, and this select initial controls was only in the demo. Default, yeah, setting some default hotkeys, more settings here, and here comes the actual game loop. We start here. So in Raylib, or I guess you can structure it a little bit like you want, but the typical way to do it in Raylib is just to have a simple while loop. This is what keeps the game running, and it's just checking if the user has decided to close the window of the game, and also have a ball that has quit, which is set if you press the exit button, for example. And just update any music stream, which is used for any sound effect that's a bit longer. So it's used for the actual music, but also a few other sound effects as well. And here, just a really big switch statement. It's like it goes on like forever, like the rest of the file. So a few thousand lines, which could be cleaned up. It wouldn't be that hard to clean this up either, because there's no real like coupling in here. Anyways, it's just pretty much code from top to bottom. So it's not as messy to work with as it looks. In the main menu, we have some menu music, and then just do the drawing. And the UI in this game is all immediate mode, which means that it's just rendering the button and handling its logic each frame by a simple method. It's not the most efficient way to draw a UI, but if you do it sort of in the same way, it's still going to be faster than most UI nowadays anyways. Yeah, so here it just checks if you have pressed this button, this frame, and renders the correct graphics for that button. Yeah, so we have the play button, the skill tree, leaderboards, settings, and exit, and that's the main menu. And this screen is not really relevant. Character render is just a debug thing I've used to make some renders of the characters. And here, character select, this one is in the game, and this is the character select screen that you would know if you have played the game, but it has the character in the middle of the screen, and you can some buttons to select the different characters and which map you want to play on. And it updates the animation for the 3D character, and yeah. go ahead and get down to the actual game logic instead. And then things also gets a little bit easier to follow. Yeah, so here's the playing part of the game. So this is run whenever you actually start like a round. And first I have a few debug things. So this is different. This is only compiled in the debug builds, and it lets me mess with some things to make stuff easier to test. Well, here begins the actual game logics. Just a few boss update things I have to check here to check if the boss is supposed to be spawned. And then we have the camera. So the camera in Raylib, I'm using the camera struct that's built into Raylib at least. It uses it has a position and the target position. So and then the direction is calculated from that. So in this I'm looking at sort of, so I'm moving the target position and the camera position, and I have so therefore I have like a camera target position and a camera target. So the target position is the position target, and the target is the target for the camera target, because I want to move the camera smoothly. I don't change the camera position and the camera target directly. I just change these target values, and then they can be used to lerp the actual camera position towards the target values, and then it's going to move smoothly. And the camera can be controlled by the keyboard or by moving the mouse cursor to the edge of the screen. So that's here, and let's see, yes, and here's the actual lerping part of that, and then some shadow stuff, just setting up the shadow camera, and yeah, that's the only thing we're doing there really. And then I'm drawing the character portrait that's like in the bottom in the UI for the character. So that's drawn to its own texture that we can then draw on the screen. Yeah, and then here comes starts the actual logic of the game, and this is divided into pretty much a function for different things we need to update. So we start with updating the player controls, and depending on which control scheme that's chosen, it runs a different method. For example, in the MOBA controls, it's going to check if the mouse has been pressed, and depending on which button you've set to move and attack, and set up all the variables needed for that. And here we comes to the actual multi-threading part of the program. If you remember the init threads at the start. So the built-in animation, like skeleton bone animation solution in Raylib, it runs on the CPU, which for me was beginning to be too slow and to run on a single thread when I wanted to have like the clones for the character. Mostly it was just in debug builds, because for some reason the Visual Studio debug builds were really built this code really slow. But then I figured, yeah, maybe that's going to be an issue for low-end more low-end devices, so I might as well add some multi-threading to solve it, and then at least it can be divided at a few cores for low-end and more cores on high-end. So this is set up in a way it's run this at the start of the frame, like start animation parallel, which releases the threads. So each thread is just running this update animation function all the time, and there's a lock here that waits for that start animation, and then here it's gonna check which work this thread is gonna do. It could either be tasked to update the animation of a clone or of the boss. So those are the things that's gonna be run on a separate thread. And then when it's done that, it's gonna wait here. It's gonna say that, okay, I'm done, and then wait until all the threads are done. And the last thread that are done is gonna reset this and release all the threads. And this method, we're gonna see that further down in the logic part. This is where the main thread is gonna wait for all the animation update threads to finish, and then when that's done, it's gonna run this, which pushes all the vertex data for the updated pose for all the models to the GPU to be rendered. And yeah, back here in the main file with the logic, we have the. So then here we start the actual game logic. We have the update player abilities, which gonna loop through all the selected abilities, and for all that has been unlocked, it's gonna check if it's gonna update the cooldown for it, and then depending on the control scheme, it's gonna check if the hotkey button has been pressed for that ability, and if it has, and it was available, then we run the do ability function, which takes the player ability and runs it. So here a bunch of things. For example, we break any channel spells if you cast an ability, and most abilities are gonna also break stealth. Some won't if you have an upgrade unlocked, for example. So we do that. We check where the mouse is pointing, because there might be an aim involved in the ability. And in case there's a controller, we're gonna take the direction from the joystick instead. And then we come to the actual ability specific logic. So here's just a big switch for all the different ability types. So we just look at one of them. We can look at the dash, the first one. So we have some specific things. For example, if there's an upgrade that's going to reset the cooldown of healing potion when you dash, that you could have an upgrade. So if that is unlocked, then we reset the cooldown of the healing potion when you dash. And dash is gonna set the speed of the dash depending on the range of the ability and its duration, and just a bunch of other things. Moxie Style says, please organize your code in folders. Yeah, it's not that many files, so I don't personally see the point in organizing it in folders. As I said before, if this was a project that was working on with other people, then yeah, then that would be then I would probably do it like that if other people wanted it. But for me personally, it's fine. It's not that many files in this project. Isn't because this game is not that big in the end. And there's some folders, like there's the asset folder, and then there's the code here. So I have folders. Player dash, yeah, and a bunch of, there could be a bunch of combo upgrades that's going to add stuff to the dash. That could be here. And then we also play a sound, the dash sound, which in Raylib it's easy. You just call like the play sound function pretty much. And this play sound multi just allows multiple instances of this sound to play at the same time, in case you would need to. Yeah, let's head back to the main thing. And then we also have like unlocked passive abilities. These are the unique upgrades. Some of them have like a passive function that's that should be run. We do that here. We can have a look at one of them as well in the play system. Oh yeah, seeing, yeah. So for example, the passive for the Lilith character, the first one, which increases the movement speed based on health missing. So this is just gonna check the current health and set this movement speed factor, which is used when calculating the speed of the player. Let's see here, for example, yeah, which is done here. We have the get player speed. There's a bunch of different factors that could affect the player speed. And we have a player status, which updates the time for any status effect, like stunned or rooted. And also like the invulnerable and unstoppable. So that's pretty much all this does. And same here, but for the clones, it can also be. And then we update the clone positions, which so this is the clone movement logic is in here, and it's quite simple. It moves in one direction until it gets too far from the player, and then it chooses a new random direction. I believe it was, yeah, random direction. It was a while ago I wrote this. Clone health. Yeah, the clones have health regen just as a player, so that's updated in here. And player animation. So this is updating the which animation should be played, and which frame of it that we are at right now. So we check if, for example, if the player is dashing, then we need to make sure, then we check if the current animation, if it's not the roll animation, then we want to set it to that. And I have a system of the current and next animation to allow for interpolating between two animations. So there's a smooth transition. One, for example, going from running to rolling. So whenever we update the animation, we set the next animation to a new one, and then we have this transition time, which is which is going to determine which part of the animation we play. So when this is 1, then we're only playing the next animation, and when this is 0, we're only playing the current animation, and anything in between them, we interpolate between them. And when this, you can see here, when this has gone to 1 or above, then we switch the current animation to the next animation, and only continue playing the current animation until we switch animation again. And depending on which type of animation state we are in, we have a few different animation update animation functions here, and these are all. I think this one is the original in Raylib, which is the one that Raylib comes with, and then I have a few edited versions of that allows for example, the transition effect, and I also have a version that can interpolate between 2 animation frames. So normally the bone animations are 30 FPS, which ends up being smooth enough for to just run it at that resolution. But for example, the big rocky guy, when he grows, the walking animation is going to be slowed down quite a lot. So to keep that smooth, I'm running this version instead, which interpolates between 2 frames. So even if the frame rate of the animation would be like 6 frames per second, it's going to be smooth, because I can take the in-between between 2 frames with this. But there's nothing fancy in that. And then there's also a split version, which is used for the Grendel's mother characters, which can attack and move at the same time. So this one is gonna. It has 2 animations, one for the bottom part of the body and one for the top part of the body. And then I have a bone that's set to be the split point, pretty much. Which decide, let's see, I think that's how I did it. Transition. Yeah, so there's a transition between these 2 that's defined on how far away from the middle bone you are in the bone hierarchy. So in the actual closer splitting area is going to use a bit of both animation to make the blend between them a bit smoother, and towards the edges it's going to only use like the top or bottom animation. But yeah, this is like a typical bone animation logic. It has the translation, rotation and scale from the animation, and combines it with the translation and rotation from the pose, the animation pose, like the base pose of the character, and adjust the vertices in the model based on these transforms. Let's see. Yeah. So that's the animation part. Check for poison damage. Yeah, that's poison damage from the boss. And play velocity. We have 2 methods which sort of doing similar stuff. It's a bit mixed. Could have been cleaned up a bit, but this one, it's sort of setting the velocity of the player, and also the target angle. And then there's also the method that updates the movement. These could have probably been in the same function. This one, the moment is the one that checks. Oh, it's only for dash. It checks against the terrain, and has some weapon dash specific things as well. Yeah, and here's this is checking against the terrain here as well. And this one, yes, this one is a little bit interesting. At the start of the game, and even in the early access release, the first version in the early access release, the collision handling was just that whenever you ended up colliding with something, the character stopped instantly, which was the easiest way to make things work, but it didn't really feel that good because all of a sudden your character just stopped. You need to click somewhere else to make it move, and especially if you were holding down like the right mouse button to move towards a direction, whenever you ended up at an obstacle, the character would just stop and you would have to completely switch direction to get it to unstuck. So I think that was the first update in our access. I made an improvement to this, which is this clamped collision position function, which basically checks the vector between the moving vector of the player against the normal of the collision box, and lets you slide along it. So it's so you never actually completely stop. So if you're holding if you tell a character to move towards something and there's an object in the way, it's going to slide against it, and if it ends up getting around the edge, it's going to be able to get to the target position in the end. This was a little bit tricky to get to work, actually. One of the trickier things. It was fun. Yeah, let's see. And also checks the same against. So this is the collision against the terrain, and then we also have, in case there's any of these prisons, which is those pop-up walls that I saw Sebastian mentioned earlier in the chat that he didn't like. So he has the collision handling against these and detection. And it's pretty much the same logic as against the terrain. Yeah, so that's that part, and here comes a few. No, this is okay. Yeah, so this is updating the prison ability, which basically just counts down the time and removes anyone that shouldn't be spawned anymore. And this is a typical way that store the data for the different abilities, for example. So each ability type, there can be a maximum of 32 active at the same time. It's mostly to just simplify things. So then I don't need any dynamically sized arrays for these. I just have a static fixed size, which makes things easier and a bit more efficient in the end as well. So pretty much all abilities are just stored in arrays like this, and this prison struct is just holding like the position and the angle and time. And whenever we need to delete anything from it, we just move the index we want to we move the last index in the last active index in the array to the position of the one we need to delete, and then we just decrement the active count of it, which since there's no need for any certain sorting of these arrays, it's a very quick way to just delete stuff in the middle of it. Movement we have looked at. Sprint damage, this is just updating sprint damage, which is an upgrade you can have for sprint. Healing circle is an ability, so this one needs to check if it has if it's time. So this is the circle that starts to. It's a green circle that you put on the ground, and it's gonna start filling in with color, and when it's completely filled, then it's gonna do a healing effect and heal anyone, heal the player or any allied characters inside it. So it checks if it's time to heal, and when it is, it checks against the player, and against the bear, and against the clowns as well, which is the typical. This sort of pattern is for a few things in the game, and this is just pretty much all the ability collision detection is based on circles, like the player radius circle that you can see when you're playing. And then all the hit boxes, or in this case circles, then for the abilities, also circles, because it's very easy to check, and easy and cheap to check collisions between two circles. So that makes it convenient. And this is all like all 2D collision checking at this point. Healing potions, that's pretty much the same things. So there's a bunch of different update functions here for the different like player abilities, and yeah, these are all player abilities. I'm not gonna go through all of them now. If there's any ability in the game you're particularly interested in, then just say so in the chat, and I can go through that specifically. Then XP crystals. So just whenever we need to spawn XP crystal, I just queue up, have an int that I add to that says it's gonna spawn a new XP crystal, and then we handle it here and spawns any crystal that needs to be spawned. Same with gold coins. And there can also be like flame strikes queued up. Some of the spawning patterns for the abilities queues up flame strikes to spawn, for example, or some others. And then we just have a list of like a queue that can be a certain amount of flame strikes that are queued up. And if the timer has been reached 0, then we spawn a flame strike at that position. Same with arc and spin ability. Update waves. This is this we can take a look at. So this is in the waves system file, which handles all the spawning of hostile abilities. So so these correspond to the wave counter you can see at the top right corner when playing the game, and which is different. Some of them are different for different maps, but we have a wave index which is directly related to that counter. And for example, wave 1 is different for the different maps. On the first map is gonna be flame strikes, and on the pirate map it's the galaxy orb, for example. But let's have a look at one of them. So it's built in a way that so we have this timer. It's just a float that counts down to when we're gonna spawn a new group of abilities in this wave. And this can be different. I set this up in these methods so it can be different between the different wave indices. And I have a bunch of constants that decides which how big these spawn groups should be for the different waves. And one inside. So for example, if there's going to be 4 flame strikes that's going to spawn in this group, then it's going to be a quarter second in between the spawns in that group spawn, for example. So not all of these flame strikes spawn at once. And if it's time to spawn a flame strike, we spawn a flame strike. And spawning a flame strike is quite simple. We just set up the flame strike struct, which and the different hostile abilities have also quite similar setup. So this one has a model and some data if it has played its sound, and position and time to impact and time to done, and its radius. And then we all just set up these values, increment the active flame strikes counter, and then add this to the lost active index in this array. And we also reset the particle spawner for flame strikes, which we can look at. We're gonna look at the particles later. So this is the setup for pretty much all the different waves. It's just gonna be different numbers and different abilities. So there's a bunch of these. And also the end wave is a bit different. That's the one like that happens after wave 20, when everything goes to shit, pretty much. And this one just gonna keep getting harder and harder. So it starts with just spawning flame strikes, and then it's gonna introduce I think it's the ice. No, it's some hooks and firefox and everything just start. At the end, it's gonna spawn pretty much all the abilities at you, just to make sure that the game ends. And it's also gonna increase the damage they do by incrementing the curse, the active curse, which increases the damage of abilities, just to make sure that there's gonna be an end at some point. All of the code is pretty straightforward. Guess that's why C is good, because it doesn't get in your way with complexity. Yeah, I would agree. It's like C sort of what would you say, like encourages you to write quite simple code, at least in my point of view. Of course you can write very complex code with C as well, if you have like function pointers everywhere, and pointers of pointers of pointers and things like that. But as long as you don't do anything unnecessarily complex like that, and just write simple code top to bottom pretty much, then I agree, it gets quite easy to follow. Then of course some things could maybe use a little bit more abstraction in this code base, but that's things you figure out after a while anyways. So if this game would have been something that I was gonna continue working on and adding a lot of more things too, then I would probably look into cleaning up some parts of this and figure out a little bit more systems to keep the amount of repeated code down a bit more. But but you don't know those parts when you start a project, so that has to come like further down the line. And in this case, that meant that there was never really need to do it, because then the project was pretty much done. Yeah, and so let's go back here. Yeah, vases, those are the yellow circles. Nothing really unique about those, and chests pretty much the same. The challenges we can have a little look at. Those are the obelisk challenges that you can activate. I guess there's nothing really surprising in here. I guess they are also just stored in an array. This happened to be just be an array of 2, because that's the max challenges that are available on any map. But they can be have a few different states. They can be activated, and they can have a time to spawn. So time to spawn means that they have been, that's when they have been activated and are waiting to spawn again. And activated means that you have stepped on the middle plate and it's active, shooting out things. And I had ideas to have more than one type of challenge at the start. This is called challenge 1, and this is, but it's the only one. And this is what shoots out the projectiles whenever needed. And it spawns. These challenge circles are the blue circles that you need to stand in to damage the obelisk. And that's a simple. It just checks if the player is standing inside the circle, and if it is, it decrements the time to break timer. And when that reaches 0, then that circle disappears. Then the challenge, the obelisk, takes damage, and we spawn some experience crystals as well. Updates and traps are pretty much the same thing, but it checks if the boss is standing in the active, and if the trap is active and the boss is standing in it, then it's gonna damage the boss. If it's not active and the player stands in it, then it's gonna decrement the timer that sets the trap. Q damage projectiles, update attack projectiles. These are the player basic attack projectiles, which they have a position, and they have a minion target index. So we're gonna get to the minions soon, and also how much damage and what speed, and some other things that affects the rendering. And this is pretty much just gonna make sure that it moves towards the target minion. Until it reaches the minion, and when it does, then we deal damage to the minion. But it could, the minion target index could be either an index of a minion, or if it's set to the maximum number of minions, then it actually means that it's targeting the boss, which is why we have this if check here. So if it's a boss, then then the boss is going to be damaged, and if it's a minion, then the minion is going to be damaged. And then we also have the actual auto attack behavior of the player. So if your player is if you're not controlling the player and the minion enters your attack range, the character is gonna start automatically attacking it. So this code is about that. It also in general updates whenever it should attack. If you have, for example, selected an enemy minion to attack directly, this handles that as well. There's a bunch of checks here. It checks if it's close enough to the target, and if it is, and if it's close enough to the target and its time, like the cooldown for the basic attack, it has is 0, then it's gonna spawn a attack projectile targeting that minion. And here we check if the player should look for a target on its own, which is gonna be doing if it's either standing still, or if you're the Grendel's mother character, or if you have issued a attack move command. And then it's gonna look through all the minions to see if any of them is close enough for the player to attack it. And it's also gonna make sure that the minion is not already destined to die. This can happen if you have very fast attack speed. So with the big attack speed buff, I realized that when you have high attack damage and high attack speed, then you would end up wasting a lot of time trying to kill minions that are already gonna die. So it's gonna pretty much have time to shoot 2 or 3 projectiles against the minion when the first projectile would kill it. So here I just check if there already are attack projectiles, any attack projectile that will kill this minion. Then we don't bother attacking it again, which makes for a much smarter auto attack logic. Yeah. And here I just made a sort of a cleanup function that just checks if any minion that has any if anything is targeting a minion that has died, for example, since we're storing the minion index, that minion could be no longer active, for example. And if the bear has been unlocked, then there's going to be some logic to update the bear. And here we come to the minion part. So let's take a look at the minions a bit. So each wave index, or each wave pretty much has a maximum amount of minions that can be active added for that wave to make the difficulty scale with the current wave index. So that's calculated here by this function. And so in the spawn minions here, I make sure that we're not spawning more minions that should be active for this wave. And also the time between spawns is also dependent on the wave index. So in the later waves, minions are going to spawn faster and there's going to be more of them. And there's also this special case here that if there's fewer than 35% of the current max minions that are spawned right now, then the minions gonna spawn much faster to make sure that the map isn't empty. So if you're really good at clearing up the minions, then you're gonna be able to spawn minions even faster. And then it's gonna select one of the different spawn points, and then just set up some default values to spawn a minion. There's also it's also going to select which type of minion to spawn, which is dependent on the wave index as well. So in the first waves, there's only can only be the basic minion that spawns, and then later, then as you increase in the wave index, then the different types of minions start to spawn. And then have a function for each minion type to set up the different stats for them. So can have different speed and health and damage. And they also have the type stored as well. And in update minion, there's nothing. There's pretty straightforward stuff here. They have an aggro range that checks that if the player is or a clone, or the player or a clone or the bear is close enough, it's gonna move towards it to attack it. And if it's within attack range and the attack cooldown is 0, then it's gonna do the attack animation and deal damage. And I think the only thing that stands out a little bit here with the minions is the anti-clump behavior. So when there are a lot of minions at the same spot, especially since the minions all move towards the same target positions in the minion path, they ended up, when I first implemented the minions, they ended up with a lot of minions at the exact same spot or very close to each other, which didn't make for good gameplay. It meant that you could very easily kill all of them with a really low area ability, but it also meant that if you got close to them, then you would instantly die because all of them would attack you at the same time. So I implemented this anti-clump vector, which goes through, it checks the minion against all the other minions and calculates a vector that tries to push the minion away from all the other minions. And when all of this is put together, when all the minions do this, then they're gonna end up moving away from each other and be at pretty much a minion radius distance from each other, a little bit more, I think, which makes for much better. It's gonna look much better and play much better gameplay wise. And this could be improved quite a lot. Right now it's n-squared algorithm, which it happens to be fine because there's only a maximum of 256 minions at the same time. But you could do some things here, like only checking like dividing the minions in a grid or an octree or something to make sure that you don't have to check all the minions for each minion. But that would only be needed if I wanted to increase the minion number by a bit. Right now it's not taking any significant amount of time of the frame time. So that's the minions. Sounds, look for XP, pickups, yeah, nothing very, not much interesting things here. Yeah, and as I said, with the abilities, I'm not gonna go through them all, the hostile abilities either, but if it is any one of them you would want me to specifically go through, then just tell me in the chat and we'll look at that one. But let's talk about the particles. So in Raylib there's no built-in particle system like there is in, for example, Unity. So I had to make one myself because I wanted to have some particle things. For example, the flame strike is made out of particles that creates that fire effect. And I just made a quite simple, straightforward one. Have this particle spawn destruct, which is, yeah, this is exactly as it sounds. It's a particle spawner. So you have a position in the world where it's gonna spawn its particles from, and then you can set like a min, a max start velocity, an acceleration. That's gonna affect the speed of the particles, and the min and max size for the particles, and a bunch of other things. It also holds the array of particles and an array of transforms, which is used for the instanced rendering, and the mesh and material for the particle as well, and some other things. Some things related to the actual spawn pattern and how many there can be, and how many are alive right now, and things like that. So for this, there's two logic methods for this. The first one updates the particle spawner, which just updates the time and checks if it's time to spawn a new particle. So it checks both checks how much time it should be between particle spawns, and from that and it also holds calculates the time since the last it updates the time since the last particle was spawned. And if it's time to spawn a particle, it calculates how many particles should be spawned in this frame, and just spawns them. And this is just a simple thing, setting up the different values that the spawner has, and adds it to the particle struct, which just has its position, velocity, acceleration, size, and a few other things. And right now there's only two types of spawn patterns. One is just spawn in a circle around the spawner, and the other one is spawning in a rectangle, and with its origin in the particle spawner's position. And then it just adds the particle to the particles array. And then next step is to update all the particles, which just adds the acceleration to the velocity, and adds the velocity to the position, and also grows the size if it's with the growth per second parameter, and then checks the lifetime, and if it's 0 below, then it deletes the particle. which is works as it deletes in all the other arrays in the game. And while we're talking about the particles, we might as well look at the render particles. It's called further down in the other file, but this is also quite straightforward. It just loops through all the alive particles and updates the transform array, and then uses draw mesh instance, which is a Raylib function for drawing a mesh with several instances with the mesh material and then transforms. This whole thing could be optimized quite a bit, because right now, for example, if there's 10 flame strikes active in the game, it's going to be 10 particle spawners for the flame strike, which each have its own array of particles. So that ends up being 10 draw mesh instance calls, which really could be turned into one. In this case, the performance was fine anyways, so I didn't bother with it, because I didn't need to render that many particles. But the better way would be to have the particle stored completely separately from the spawners, and just have the spawners add to a global particle array, for example. At least you could have one for each type or something, and then you can render them all in one go. This is done for all the different particle spawners in the game. And I also have dynamic lights for one thing, and it's a flame strike. It was just something I thought was fun to add at the start, but then I never added any more, because dynamic lights gets complicated and expensive if you want many of them. So one of the flame strike is gonna emit light, and that's done here for the different shaders that are affected by light in the game. And here's the shadow map thing, which is a pretty standard shadow map implementation. This just sets up the render state for to render to the shadow map texture, and then have a function draw shadow casters, which just have draw calls for all the things that should cast shadows in the game. So I just render everything, but with this with a shadow shader instead, and then the shadow shader just has a different fragment shader that doesn't render anything. It just writes to the depth buffer, because that's the only thing you need for the shadow map to make things a little bit more optimized. And yeah, and this shadow texture is then available for all the materials when rendering the real stuff, so they can check if the pixel should be in shadow. And here comes the rendering for the game. So that's also a bit messy, because all the rendering is here in the main loop directly. Never bothered to sort of make a concept of a renderer or something, or should probably at least have split them up in different functions, but never got that. Except for the level. The level is in its own. And this one we looked at before is the one rendering the level model. Attack projectiles. This is only used for certain projectiles. So some of them most of the basic attacks are particle based, but for example the stone stone character and the ranger character have models instead, and then we render those here in case that character is active. And the different abilities are at least divided into functions. And this renders the prison ability, which is just made of 1, 2, 3, 4, like 6 different pieces, different models. That brings up this the wall. And pretty much all the rendering is using this draw model function in Raylib. It's not the most optimized way of rendering things. It's a bit of it's a bit overhead in this, but it's what was available out of the box, and I didn't bother to make anything more optimized in the end because it wasn't really needed for this quite simple game. And then when drawing the player, we do things a little bit differently. For example, we check if the player is in stealth, and if it is, then we set the alpha of the color, so it's gonna be a little bit transparent when rendered. And there's also a special effect for when the player is in the weapon dash, it's gonna glow, but otherwise we just draw it without any modifications. And yeah, so the rendering is quite straightforward for pretty much all the things. And here comes the lock for the parallel handling of the clone and boss animations. So when the render thread gets here, if any of the threads handling the animation updates for the clones and the boss isn't done yet, then it's gonna wait here until that's done. So and then render the clones and the boss after that. And then the crystals, those are drawn as instanced things because there are quite a few of them. Same with the gold coins. And there's some changes in blend mode every now and then. Some things are rendered with the additive blend mode, and some things I disable the depth mask to make sure that things are not blocking like alpha textures and things like that, to pretty much avoid having to sort them in its own pass. I just have like a static sorting of different objects by ordering the rendering in this way. Yes, and the different minions are mostly rendered some of them are rendered just by draw model, and some of them are rendered with instances. Render particles. Yeah, and here we'll start rendering particles for the different particle systems. Some and Yeah, and here's pretty much all the other particle systems as well. And the air minion, yeah. So the order here is just to have it be to make it yeah, it could be optimized a bit. I think quite a few things here by trying to optimize the different draw passes with additive, and to not have to switch between additive blending and normal blending or alpha blending, for example, as often. But since I didn't really run into any performance issues on the graphic side, I just let it be in the way that was simple enough to set up. And yeah, so that's all the rendering for the 3D stuff. And then comes the in-game UI, and all the rendering, all the 3D stuff is rendered to post-processing target texture, which it is to allow for doing some post-processing stuff. Have a post-processing shader. I think it's not using, let's see what effects. I think it's only gonna be active on pretty much one map. Post-processing, it's in here. So I do have support for a lookup table texture. I don't think I'm using that at the moment, because I ended up being happy with the colors as they were. But there's also a fog effect here that's used at least on the desert map, but yeah, you could put in some more post-processing effects with this. And then we do another pass of rendering, which is, yeah, so this is actually a pass of 3D rendering again, but this should not be in the post-processing target, because this is the UI stuff, and we don't want to change that. We don't want to add fog or change the colors or anything on, or add bloom or something on like the health bars for the minions and player that's inside the game, because that would look a bit weird. And for example, the minion UI is gonna be, that's just gonna be a model that's basically a rectangle with the color, or two rectangles, actually, one for the background and one for the actual health bar. Same goes for the loot progress bars and the player health bar and everything. And when that is done, then we're done with all the 3D, and then we're rendering the 2D parts of the UI, which is like the different backgrounds for the UI, the text, and for and rendering the ability icons and everything. Yeah, I think that's pretty much it when it comes to yeah, and here's like the tutorial texts and things like that. Yeah, and that's it. And then we have the settings. That's not much interesting there. We could take a little look at the upgrades, I guess, which is the skill tree. And the skill tree is made of, let's see, here, nodes. So it's okay. No, this upgrade nodes. Yeah, this is it. So the skill tree is just pretty much a graph of nodes. It starts in the middle and then branches out. So each node has a position and an icon and an upgrade function, cost and all that stuff. But it also has an array of indices to this nodes array, which is nodes that is connected to, that is going to unlock if you unlock it. So this is used to know. This is used to tell the connections between them. So each node can be connected to any number of other nodes. And I started setting things up like this in code, with all the positions and all the different what do you call it? All the connections. But that was really painful. So then I actually took some time to write a skill tree editor. Let's see if we can have that visible on the stream. Yeah, so here's the the skill tree editor, which allows me to move the stuff around, and I can also, let's see, I can also add connections and see anyone that's, yeah, I could add. Yeah, from this, let's add one from this. We can have the, I need a bigger window, the banish, and then the connection is gonna be made between them, which means that if you unlock this ability, then this is gonna be available to unlock as well of the. So this made things a lot easier. It's very simple, and but it gets the job done. And then I have the cleanup position, which finds a position that's based on some distances that I have set that I want to have between them, and just cleans everything up. So there's nothing that's off center or like off like this, and then just gonna clean it up, and then it's just gonna then you can just save that to a file, which is then loaded by the game on startup to know where everything should be. And that made things a lot more easier, so I didn't have to set everything up manually like this. I did that with a few, and then after a while I added a skill tree editor, and then I just started to add the data like this with just the names and things, and then all the connections and positions comes from the editor instead. And let's see, yeah, and then render node. Yeah, let's look at the render part. Render skill tree. So rendering the skill tree basically just means walking through let's see. Yeah, walking through the tree pretty much. So could be, yeah. So it's gonna take the first, yeah, thanks. Pretty cool skill tree editor. Yeah, thanks. It was definitely worth it. It took a little while. I think I spent maybe, it wasn't that, maybe a few days or a week or something. So it wasn't that much work, but it was definitely worth it in the end, because writing things up in like writing things, positions and connections manually in code just gave me a headache every time I was doing it. So I needed it for my own sanity, and I can reuse it for any other game in the future as well that needs a skill tree, which is pretty common in games. So I'm sure we're gonna have use of it for future games. But to render stuff, it's gonna start with the middle node, and then just gonna call this render node for all the nodes connected to it, and this is just a recursive thing pretty much, which is it's gonna render the node, and then just say that, okay, this node is rendered. I have a mask, which is just an like a 64-bit integer array, which is a bit mask that stores. So I can store any node that has been rendered, because as you maybe could see, they could be like circular dependencies, or sort of in the skill tree. So we don't want the algorithm to end up in an infinite loop and try to render the same bunch of nodes all the time. So I just set this mask, and here at the start of the render node, we just check if this node has already been rendered. Then we know we all have been down this path, and we can just return. But then we just keep going deeper with all the connected nodes, and this is gonna run until we end up here for all the leaf nodes in the tree. And we do the second pass with for the lines, which is rendered in a similar fashion. We just check 2 nodes here instead, and draw a line between the 2 of them. So draw, yeah, and then if one of the nodes have been selected, just draw the upgrade button and the information about that upgrade. Yeah, and some code to handle navigating with the controller. This one is definitely a bit janky. I would have liked to have done a better job at supporting controller navigation in the skill tree, but it's usable. It's not that good, but yeah, it was it was really boring to try to get it to work better, so I wanted to move on. Yeah, and this is the controller logic, check node selection. Yeah, and then each node has an unlock function that just upgrade function that just sets the state, changes the state for the variable that's needed to do the upgrade. For example, if you unlock blink, then unlock blink is set to true, and if you increase the circle, if you upgrade the circle time upgrade, then this upgrade is incremented, and all these values are saved to the save file. So these all get loaded into when starting the game. Yeah, I think that was the skill tree, and yeah, leaderboards. There's not that much interesting stuff in there, UI wise, and that's pretty much it. Yeah. So that is the code walkthrough, pretty much. I am gonna, yeah, let's answer the question about, I'm not sure if Sebastian is still here, but what was the biggest challenges with Sidestep Legends? So I can talk a little bit about that towards the end, and if anyone has any other more general question about the project, feel free to ask them, otherwise this is probably going to be the last part. And the biggest challenges, I'm not sure that this game was, like, in general, this is not that complicated of a game, so there weren't any really big challenges. I guess using C and Raylib was new for me. My previous games I had been making before this had been done in Java, actually, with a library called libgdx, and also been 2D games. So this being 3D was a bit new. I had been working with 3D a bit, I guess quite a bit before in Unity on my then day job. But it's a little bit of a different beast handling 3D like this and doing it in Unity, because Unity has pretty much everything done for you, like the whole renderer and calling and everything. And Raylib comes with a lot of important stuff to get started, but there's also more things you need to do yourself. Integrating Steam was a little bit tricky with this, since I couldn't rely on the official documentation that much, or at least had to, since that was for C++, and they have like a whole callback system that's implemented in C++ for all the events, that I had to redo a few things for. Had to implement some of them myself to get that working. Let's see, it's Steam, yeah, around Steam callbacks. So it didn't end up being that much code, but it was a bit tricky because it wasn't clear which events were which callback type. So I had to sit a few days to debugging stuff with the Steam client in debug mode, and try to see why events weren't being called when trying to read the leaderboard, for example, and things like that. And it ended up being just that the event wasn't being sent in the way that the API sort of said that it would, and it was just being sent in another way. So things like that, I guess, were the more tricky stuff in this development. Yeah, and but I think that's gonna be it for today. And so thanks everyone that's been watching, and make sure to check out the game on Steam if you haven't already. And yeah, have a nice weekend. Bye bye.